Hello, everyone. Today we continue our course about sustainable packaging and product innovation uh, with part number one, sustainable packaging, eco-friendly materials. And then we will talk about part two, three, four, five, and six in the other videos. For part one, for today, we will talk about design for recyclability and renewable and recyclable materials. Eco-design principle is one of the master challenges for industry because it requires different requirement for materials, for formulation, and for design and the choice of the materials to develop the packaging of each industry dependent of their product. For example, in this table, as you can see, design aspect with different materials, monomaterials design with color and inks for each materials. And the choice of this design, it impacts effectively the quality and of your packaging and then the quality of your product. By integrating recyclability criteria, this criteria for design stage manufacturers can reduce waste, for example, improve waste food and then improve the quality of their products. About materials and structural consideration, it is very important to choose the materials for different considerations such as low cost of production, adequate physical properties, quality of the product, as you can show in this, as you can see in this figure. And then it depends also for safety of the product, scalability, and application of the product, the area of and sectors applications. In this table, we developed the different criteria such as layers, additives, size, and shape, and then the ingredients that we use to choose the materials to develop the packaging. Additional criteria include minimize additives using compatible adhesive, for example. And then all this information make the product and make the improved quality of the product and then give you a practical packaging to use for your product. A design for recyclability with and impact environmental with system level impact. As you can see in this slide, design, packaging, and recyclability delivers measurable environmental benefits, include reducible landfill use, lower demand for virgin raw materials, and described greenhouse emission. All this information leads that the design of your product will impact different axes: quality axis, production axis, cost axis, and then environmental axis of your product. Therefore, design of your recyclability must be integrated with consumer education, infrastructure development, and complementarity eco-design principles such as material reduction and rules. And that's one of trends, one of the best questions in industry and different sectors such as food, cosmetic, and pharmaceutical industry. On this table, we can make see this benefit of the choice of the materials and limitation for different infrastructure of your products. In this section, we will talk about bio-based alternative to fossil resource. Alternative resource is one of the question of eco question and the environmental question to replace the plastic ingredients with the bio-based plastics, for example, polyethylene, and for example, polylactic acid, for example, and paperboard, for example, or use of cellulose films. These ingredients we can find it in different sources, such as wood pulp, for example, corn sugars, and forest biomass. The choice of these ingredients make your product, your packaging and bio packaging with eco characteristic and that make with high quality for to preserve the quality of the food and also for environmental protection of environmental. For closing the materials loop, as you can see on this slide, if in food packaging, the use of recycled materials is a subject of the strict safety regulation. This regulation in Europe, but also in all of the world, in the US, for example, it's a question, world question about the choose of the materials, advanced research, advanced recycling technology, and the decontamination process have explained the range of food contract application designer must consider quality, availability, and regulatory compliance with specific recycled content. For example, and recycling polyethylene thiophthalate, for example, we typically specifically for beverage bottles, for example, and the recycled paper for secondary packaging. So the choice of the material is one of the best question. The question for that industry asking for develop the formulation of their packaging. About strategy and selection of sustainability packaging, it depends on different factors. These factors, there is some practical factors relative to the formulation of the product, but also to environmental aspects. Decision making should consider the life cycle, for example, impact, technical requirement, regulatory constraint, and local infrastructure. A life cycle assessment approach enable objective comparison and avoid innate trap for us. So objective of this course to make a student should understand the material selection and a context dependent and must align with both sustainability objective and function performance. And this we will develop this part in the practical section. In this table, we can see some example of criteria such as resource origin, criteria, circularity and regulatory complexity of the ingredients for regarding renewable materials and recycled materials with different quality for markets. This is all for the part number one. We move to part number two, such as sustainable food processing. We will talk firstly about sustainable food processing, about the scope for this part. We will talk about the application of the processing of the food and the choice of the packaging, of the material of the packaging. This part focuses on practical approach to sustainable and food processing, emphasizing water management, waste reduction, waste valorization, and industry symbiosis. This strategy demonstrates that sustainable can be integrated in daily operations throughout the better management, technology, and collaboration. The objective of this part is that the students are encouraged to view food processing part of a wider system linked to packaging, logistics, and environmental performances. As you can see, for example, in this picture, step by step for sustainable food systems in food industry. And environmental challenge is one of the principal question for this area, for this sector of sustainable food processing, because a lot of factors are concerns in this question. Food processing contribute to environmental pressure throughout higher water consumption, for example, energy use, greenhouse gas emission, and waste generations. So develop the packaging is one of the question in the environment and with the respect and for environmental and question of the and all this question relative to water consumption and energy use. Recognizing environmental challenges help to identify priority areas for improvement. Sustainable processing does not mean just reducing production, but optimizing process to achieve the same output with fewer resources, with other alternative and other resources regarding the use of water or the use of bioresource energetic. About link between processing and packaging, it's a bridge, very important bridge between this area. It's very important to because on all industry, on all systems, food systems, the process and packaging is used. So processing and packaging decision are closely interconnected. Process and condition influence product characteristics such as moisture, content and shelf life of product, and quality, sensory quality, nutritional quality of the product. So the choose of the packaging, the choose of the process, it's relieves a principal question for agri-food systems. About importance of water and food industry, it's one of the question. It's one of principal point of the success of agri-food system in an industry. As you can see in this table, main use of water and food processing with different applications. For example, drought, the production chain, step by step. For example, for washing, for processing, and for CEP cleaning, you can see the purpose of and the use of water. And then consumption of the water is very high consumption. So the question of the of economic of water is very important for the industry and to optimizing the step of production for that use the water in each industry systems. Water consumption hotspots, as you can, is unevenly distributed across processing operations. Cleaning and place systems often represent the largest share of total water use, followed by washing and processing steps. And there is other operations that we use of water with high quality, with the high quantity. So mapping water flows across the production lane provides a baseline for monitoring and optimization. Once hotspots are identified, technical and managerial solutions can be implemented efficiently. As you can see in this graph, with the importance of use of water consumption and different food production for bread, for beer, green beans, for example, with 30 that, and for whiskey, for example, we have to 33 percent of consumption of water. The percentage of water consumed is very high, and it depends of the activity of each industry. About principle of water efficiency. Water efficiency is based on three principles: reduction, reuse, and optimization. Reduction focuses on eliminating unnecessary water use throughout the better practice. Reuse involves to recycling water and the process where the food safety flows. And optimization improved equipment and cleaner protocols and improve the parameters. Use some other materials, new technologies to optimize the consumption of the water for any industry. And this table we present some principal technology, principal use for reduction, reuse, and optimization with the different description and example of technology that are used for consumption of the water. About water monitoring and control, effective water management requires accurate measurement. Water meters and digital monitoring systems enable real-time taking of consumption and early detection in infections. Monitoring also support compliance with environmental regulations and sustainability reporting for students. This highlights the growing role of digital tools in sustainable food processing with use of some sensors tools, some AI technologies. It's one of the best trend area of the technology to optimization of water consumption. Water recycling concept is also one of the principal question for different industry with the regulation that encourage the use of this type of recycling conception with different systems. The objective is dependent of treatment level. Recycled water can be used for cleaning, cooling, or auxiliary operations. So the choice of the technology depend of the nature of processing, of step of each production chain. Recycling reduces fresh water without and wastewater discharges. However, water recycling must always respect food safety and hygiene requirements. In this figure, as you can see, there is an example of wastewater, as you can see, and objective is to make this sustainable wastewater treatment technology using, for example, some bacteria, some microorganisms to do the treatment of the water, and then they make this water recyclable and used for new for industry or for other agriculture or for different application. Water recycling technology, a lot of technology and new technology are used on this objective, such as filtration, such as ultraviolet analysis, such as the new technologies, the objective and the biotechnologies are used to do a recycling of your water with the different treatment level. We typically use, for example, for pre-treatment for process rules and for hygiene, we use UV UV just for hygiene quality and avoid microorganisms and bacteria of the water. About benefit of water recycling, a lot of benefit. Water recycling reduces environmental impact, lowers cost, and increases resilience to water scarcity. It's also improve corporate sustainability performance and regulatory compliance. This benefit make water recycling a strategic investment rather than only an environmental measure for different industry, because this question is also a cost question and is a quality question for product, is also a question of transparency with the consumers and make a product with quality, with high quality for the consumers. About the type of processing waste, a lot of type food processing generate organic waste, water sludge, and as you can see in this figure, with different waste for issued from different industry, fruit, catering waste, packaging, industrial waste, domestic waste, and all this type of food processing waste. There is an important question of valorization of different waste to make their useful and recycling. About waste reduction sources, there is a lot of, as you can see in this slide, preventing waste generation is the most effective strategy. Different strategy applied, as you can see in this table, for different action processes, optimization, training, equipment upgrade with different impact and costs. About valorization, a lot of valorization concept of waste valorization, as you can see in this document from, for example, for fruit, vegetables and food development, anaerobic design, digestion, and then anaerobic converter for organic waste. And then biogas for this technology is emission. For example, and in general, it used the biotechnology to treat for treatment of the waste and then produce recyclable water. Other waste of energy technology is incineration and gasification of pre-valorized recovered energy from non-recyclable water. These options are used often for prevention and also for recycling, as you can see in this table, with different technology applied on waste type output for biogas, for heads, for gas, and other technologies. Just an example of different technologies. About industrial symbiose, it's one of the principal question and valorization of the water. This creating a bridge between recyclation of the water and development of the product. This approach improve efficiency and reduce environmental impact with using biomass and the biotechnology, biomass, bacteria, or other microorganisms to develop energy from the waste and to create value for their product. Application in food packaging industry, food waste can be used for produce, packaging, materials, energy for nearby facilities. There's collaboration enhance sustainable and local economic resilience, as you can see in this figure with the this valorization of the waste for different area, for different sectors, for fuel, for gas, for electricity, using this application of recycling and valorization of the wastes. Measurement sustainability performance is one of the application that industry use to create sustainability benefit with different indicators such as water use, energy, and waste of different product. It depends of the objective. It is to preserve footprint, energy use, and waste reductions. About environmental and economic benefit also, regulatory is one of the best question and the principal question for industry to application of this concept of recycling of the recyclization of the water and use of the biotechnology, use of the to preserve the valorization the waste. Regulation and market expectation increase in requirement, sustainable process and practice, early adaptation, improve compliance and competitiveness. And finally, for this part number 2, sustainable food process and focus on efficient water use, waste reductions, valorization, and industry collaboration. This strategy reduces environmental impact while improving economic performance and system resiliences. Using different technology, that is one of the area of new technology, new researchers, and different laboratory. And our laboratory also we work about development of technology, new technology of valorization of compostable waste to create the energy, to create electricity, to create value based on the waste. That is all for this part, and we will continue with part number 3 and next video. Thank you.